Dear student, today I will discuss about Deadzone nonlinearity. This is a very common type of nonlinear features for any kind of linear systems or plans. So this is the characteristics of Deadzone nonlinearity. In these characteristics we can see that in x-axis there is input signal and in y-axis there is output signal. So when we give the input signal to that particular nonlinear elements or nonlinear blocks, then we can see that for a particular time length, for a particular range of input, the output will be 0, and after a certain time in x for the positive input and for the negative input, we are getting the output from that characteristics from that nonlinear blocks, and the nature of that output is just like a ramp function. And here we assume that after a certain input of d and minus d, we are getting the output for that Deadzone nonlinearity with the ramp function, and the slope of that ramp function is k. So as an input function we are assuming that xt is equal to x sine omega t. So when we give that xt input to that Deadzone nonlinear blocks, we are getting the output that is yt. So there will be some range. For that particular range, and we are getting the value of yt for the different ranges of input signals. Suppose yt is equal to 0 when omega t lies between 0 to omega t, then we are getting k into xt minus d, and we are again getting the value 0 for different kind of ranges. Now we can see that yt is a odd function and it is a symmetrical function. So for that n is equal to 0, and as well as the dc component a0 is also 0. So for this case, when we expand the function by using the Fourier series, then we only get the fundamental harmonic component, that is bn. So then the function will become only y1t is equal to b1 sine omega t. So where b1 is equal to 1 by pi integration 0 to 2 pi yt sine omega t d omega t. If we go for the integration part, then first we change the limit from 0 to pi by 2. So this part will now become 4 by pi integration 0 to pi by 2 yt sine omega t d omega t. Now we put the value of yt, that is x sine omega t minus d, in this equation. After putting that value, we just go for the integration part, and now for this case we just assume that d is equal to x sine omega t1. So if d is equal to x sine omega t1, then omega t1 is equal to sine inverse of d by x. So we just put the value in these equations, that is 4k by pi and integration from omega t1 to pi by 2 x sine square omega t, and instead of d we just put x sine omega t1 into this one sine omega t and d omega t. So after putting the limiting value of that integrations, we derive that b1 is equal to 2k x divided by pi into omega t minus sine 2 omega t by 2 plus sine omega t1 into cos omega t, and the limit is pi by 2 to omega t1. And now we put the value of the limit in these equations, in the previous equations, and after that we are getting the value of b1, that is 2kx pi by pi into pi by 2 minus sine inverse d by x minus d by x into square root of 1 minus d by x whole square. So this is the output part of the system, that is p1. So now we have to derive the describing function. As we know that describing function means the output function divided by input function. So here output function means yt, which is just equal with b1 sine omega t, and the input function is xt is equal to x sine omega t. So when we put these two value, b1 sine omega t and x sine omega t, then sine omega t will be cancelled out from the numerator and the denominator part. So only b1 divided by x part is remain here, and which is the magnitude, which will define the magnitude of the describing function. And for the phase angle, here we write here 0 degree, because as we know that the input function is x sine omega t and output function is b1 sine omega t. So for the both cases, for the input and output functions, the signal is just a sinusoidal wave, and the angle of that sinusoidal wave is omega t. As there will be no phase difference or angle difference between the input signal and output signal, so that's why the phase difference is 0 degree. So we just put the value of p1 here, and we got this result. Now we have to apply this thing in the practical cases. That's why for the simulation purpose we just draw a block diagram where the input, as an input signal, we just take sinusoidal wave. There is a summing point. This is a nonlinear block, Deadzone. Next, this is the transfer function block. This is the multiplexer box, 4:1 multiplexer, and finally the output box, that is known as scope. So here we just draw the block diagram, and if you apply this block diagram in the MATLAB Simulink, then from the scope or output part you can easily find out the nature or characteristics of this total system. So to observe the characteristics, we just took here 4 channels. One is the output signal, one is error signal, another is nonlinear signal, and another is feedback input signal. So 4 channel is there. Thank you.